Today we're going to be talking about section 4, which is properties of logs, solving exponential and log equations. So hopefully you remember from last year the way to switch from log to exponential form. So if you have something in exponential form, such as b to the a power equals c, then hopefully you remember that you can switch that into log or natural log form by doing log base b. So the base goes in the basement of the log, and you're using this to solve for exponents, so that's what it equals. And so the c just goes on the same line as the log. So based on that information, if you have log base b of b, that's asking you b to the what power equals b, which is just 1. Or b to the what power gives you 1. Anything to the 0 power equals 1. This one you could say b to the what power would give you b to the x. So since the bases are the same, their exponents have to be the same, so that would just be x. And if you have b and to the log base b of x power, if you switch that to exponential, or to log form, sorry, it would be log base b of the question mark equals log base b of x. So the log parts are the same, the base is the same, so therefore that has to equal x. So there are several different ways you can solve these. You could switch it to exponential or log or natural log form, depending on what you're in to begin with. If you're in exponential form, you could take the log of both sides. Or if you're in log form, you could exponentiate both sides. So you could make it into 10 to that power or e to that power. So let me show you a few of these methods. For the first example, we have natural log of x equals 3. Personally, I would just switch it to exponential form and solve it, but if we wanted to exponentiate both sides, again, hopefully you remember that e is in the basement of a natural log, so we'd want to take this to the e on both sides, so make it e to the natural log of x equals e cubed. And then using our same information we had up here, when the base, if we use this one, when the base and what's in the basement of the log are the same, that just equaled x. So in this case, we must have just x over here. It has to equal e cubed. So x is approximately 20.09 if you type that in your calculator. You can do the same thing with the second example. We could exponentiate both sides. And since we don't have a number in the basement, remember that you assume it's a 10. It's a common log. So we could take both sides and make it 10 to that power. So 10 to the log of x equals 10 to the 0.27. Again, from that same property we just illustrated, the left-hand side just turns into x equals 10 to the 0.27. So if you type that in your calculator, x is approximately 1.86. For the third example here, we need to get it into just simply exponential form. So what we had up here at the top, our b to the a equals c. That's the form we want to get it in. So the first thing I would do is add the 11 to both sides and divide by 2. And then I would, like I said, do method A and switch it to exponential form. Or sorry, switch it to the natural log form. So it's e, so go natural log. So I always write it in cursive so it doesn't look like 1n or in. So the natural log of 17/2 should equal x. So again, if you type that in your calculator, x is approximately 2.14.